we are starting with the Einstein's theory of photoelectric effect. So till now we have seen various other theories of photoelectric effect, and now we are going to start Einstein's theory on the photoelectric effect. So as we have already seen that when light falls, light with certain frequencies falls on a metal surface, the electrons come out, and therefore there is a flow of electron in the circuit, which we call it as photoelectricity. And the photoelectrons are the reason for this photoelectricity. Why we call it as photoelectron or photoelectron emission? Because this electron emission happens due to the falling of light or due to the light. So let's see as to what Einstein has given us a theory of photoelectricity. So around 1905, when Einstein used Max Planck's quantum theory of light. So actually Max Planck has given the whole quantum physics picture, and using Max Planck's concept or taking that concept, Einstein had used the same concept into the photoelectricity, and then he had tried to explain the whole photoelectricity or a whole photoelectric effect. So according to Einstein, and with the help of quantum theory, what Einstein told, that light is not just a wave, as we have seen that wave nature of light cannot explain the theory of photoelectric effect, or it cannot explain the photoelectric effect. So we cannot explain definitely this with the concept that light is a wave. So rather Einstein have imagined light as small packet or small quantas of the energy h nu. So this small packets or the small quantas, this is what is the concept of the quantum theory given by Max Planck. And this small quantas of light packet, Einstein has called it as photons. So these photons have certain energy, and this energy depends on the frequency of the light. This energy is given by h into the frequency of light, or h nu, where nu is the frequency of the light and h is called Planck's constant, right? And the energy of this photons is given by h into nu. And the small packets of energy, Einstein named it as photon. Therefore, these photons are actually hitting a metal surface. So what is happening when light is falling on a metal surface? Actually light is nothing but the small packets of this quantum of energy, or we call it as photons. So as these photons are hitting, there is this particle called electron, and when there is a collision taking place, when the photons are colliding with the electron, if there is sufficient of amount of energy, if the photon has the sufficient amount of energy, then it can release an electron out, and therefore we get the photoelectrons out from the metal, and that's how photoelectric effect is happening. So what is happening here is photons with a certain amount of frequency have certain energy, and if that energy is enough to knock this electron out, so when they are colliding with the matter, when they are colliding with this metal surfaces, this electron are colliding with the photons, and therefore these photons are able to transfer completely its energy to the electron. The energy that is minimum required for the electron to escape, that we call it as work function. We call it as work function, which is denoted by phi. So this is the minimum amount of energy which is required for the electron to just escape this surface of the matter or the material surface, and therefore the energy of this incident light has to be more than the work function. And whatever the extra amount of energy, after knocking out whatever the extra amount of energy is there, with that energy, that is what is the kinetic energy. With that energy the electron would start moving, and that is the kinetic energy with which the electron is moving out. So this is what the picture that is given by Einstein. So what we see here, that as we already know, there are certain amount of frequency of light is needed to eject the electron out, and here Einstein is also telling the same thing, that when a certain amount of frequency of light with an energy h nu is falling, and this has the energy which is at least equal to the work function, then that is a minimum energy required for electron to just escape. And if the electron has to escape and then come out with a certain kinetic energy, then we can write the energy here is firstly used to take out the electron, that is the work function, and then the rest of the energy will be ejected as the kinetic energy. So here what we see, this energy of the incident light is nothing but h nu according to Einstein, and this energy is first used to lose the electron out, just the electron escapes from the surface, and the rest of the energy is used as a kinetic energy of the electron. So what we can see from here, which is the Einstein's equation, it says that the kinetic energy of the electron would be equal to h nu minus phi. It's from here. The kinetic energy is maximum, that we have already seen that this kinetic energy is the maximum, which we have called it as k max, and also k max will be equal to half mv max square. So the maximum velocity with which the electron would come out will be equal to h nu minus phi, means whatever amount of energy that you are providing, or which that depends on the frequency by which you are providing this. So with the frequency, when we are with a particular frequency, when that frequency of light is falling, and that frequency of light is partially used as to eject the electron out, that is the work function, and rest of the energy is transferred as half mv square, or the kinetic energy, maximum kinetic energy with which the electrons are coming up. So this is Einstein's theory of photoelectricity, where we see that there is a collision taking place between photons and the electrons. So here necessarily the first idea that Einstein is using here is not light as a wave, but light as a small packets of energy with a particular frequency, has a particular energy, and this energy packets are called photons, and this energy is discrete, it's not continuous, so they are having discrete energy quantas, they are called quantas, and they name it as photons. So when the photons are hitting or colliding with electron inside the atomic surface, these electrons would use certain amount of energy to just lose out or to come out from the surface, and rest of the energy is used to take the kinetic maximum kinetic energy of the electron, so that it can just come out as a photoelectron, and thereby we get the photoelectricity. So this in general is explained by Einstein with the Einstein's theory of photoelectricity, and this is the equation that we get. This is called Einstein's photoelectric equation, which has half mv max square is equal to h nu minus phi.
If you like the video, then press the like button, subscribe to the channel and press the bell icon.